Hey everyone, welcome to This Explainer. I'm really pumped you're here today because we're diving into the exact thing that separates a casual scripter from a master software architect. We're looking at the absolute bedrock of writing modular, highly maintainable Java code. If you've ever felt like your project is just slowly turning into this unmanageable mountain of spaghetti code, trust me, you are not alone. By the end of this explainer, you're going to walk away with a scalable enterprise-level blueprint to fix exactly that. Let's get into it.
Every junior developer eventually hits this exact wall. Writing 100 lines of code for a quick little script, that's easy. It's actually really fun. But maintaining 100,000 lines of code over months or even years with a bunch of different people touching the code base, yeah, that quickly becomes a total nightmare. Because without a solid structural blueprint, those massive projects just devolve into these fragile, error-prone systems where fixing one tiny bug somehow magically creates 3 more. We have all been there.
Okay, so here's our roadmap for today. First, the large project nightmare. Second, encapsulation, shielding your data. Third, inheritance, reusing existing code. Fourth, polymorphism, flexible object behaviors. Fifth, abstraction, hiding the complexity. And finally, number 6, the maintainable codebase. Let's dive right in.
Section 1. The Large Project Nightmare.
Moving right along to Section 2, encapsulation, shielding your data. Let's look at our very first pillar. So what is encapsulation? Well, it's also known as data hiding. It's basically the practice of wrapping your data, meaning your variables, and the code acting on that data, your methods, together into a single self-contained unit. Now in Java, you usually pull this off by locking down your class variables. You just make them private. And then you carefully provide public getter and setter methods to access or modify them.
A really great way to think about this is like a medical capsule. It mixes a bunch of sensitive, raw ingredients and hides them safely inside a protective shell. When you take the medicine, you only interact with the shell, never the raw ingredients inside. And in Java, we literally mirror this. Check out the snippet here. You've got your private variables safely locked inside the class shell, and the outside world, it can only interact with them through those strictly controlled public get and set methods.
So why does this matter for a huge project? The crucial point here is that encapsulation fundamentally protects your data from accidental corruption by outside code. Think about it. When you control exactly how data gets changed through a setter method, you can validate it first. It acts like a blast shield against rogue scripts. That means a junior dev working on a totally different file can't just accidentally reach across the project and overwrite your core database connection variable. It's completely shielded. But here's the thing. As your project scales up, shielding your data is really only half the battle. So what happens when you have 50 different types of objects doing essentially the exact same thing? Writing 50 separate, fully encapsulated classes completely from scratch sounds totally exhausting, right? Which brings us to Section 3, Inheritance, Reusing Existing Code. This is our second pillar.
Inheritance is incredibly powerful. It allows a new class, which we call a subclass or child class, to automatically inherit the properties and methods of an existing class, the superclass or parent class. So instead of starting from a totally blank page every single time, your new objects can just absorb the capabilities of the ones that already exist.
Let's break it down with a simple analogy. Think of a dog. A dog naturally inherits traits from a general animal category, right? All animals eat and sleep, so a dog gets those behaviors automatically. But it also has specific traits of its own, like barking. Looking at the Java snippet, that single word extends is a game changer. Saying class dog extends animal means our dog class instantly knows how to eat and sleep without us writing a single line of that logic. We literally just add the void bark method and we're good to go. Now, think about what this means when you're trying to maintain a massive code base. It promotes absolute massive code reusability. You're not sitting there copying and pasting redundant code all over the place. And more importantly, it creates a super reliable single source of truth. If you realize there's a bug in how your animals sleep, you just fix it once in the parent class, and boom, every single subclass instantly gets the fix. It drastically cuts down on typos and those really annoying logic errors across enterprise projects. Okay, so we're hiding our data, and we're inheriting shared behaviors to save ourselves a ton of time. But that sets up our next major hurdle. Once you have dozens and dozens of these inherited objects flying around, dogs, cats, birds, whatever, how do we handle them all without writing rigid, duplicated instructions for every single specific type?
Let's look at Section 4, Polymorphism, Flexible Object Behaviors, the third pillar.
Polymorphism literally means many forms.
It allows objects of different classes to be treated as if they were objects of a common superclass. In Java, this usually plays out in two ways. First, method overriding, where subclasses provide their very own custom implementation of a parent's method. And second, method overloading, where you have methods sharing the exact same name but taking different parameters.
Think about a standard play button on your phone. If you press it on Spotify, it plays audio. If you press it on YouTube, it plays a movie. From your perspective, the action, hitting play, is exactly the same, but the behavior dynamically changes based entirely on the app or the object you're using. And the Java snippet here shows this beautifully. We call the exact same overwritten play method, but it acts totally differently depending on whether it's an audio object or a video object running it.
For maintaining a huge project, this is absolutely a game changer. It lets you write flexible code that treats different types of objects uniformly. Instead of writing these massive, super fragile chains of if-else statements just to check every single possible object type before doing something, you literally just say play. The object figures out the rest on its own. So when your team needs to add a completely new feature down the road, this flexible code scales up smoothly without breaking everything else.
All right, moving to Section 5, Abstraction, hiding the complexity, our fourth and final pillar.
Abstraction is all about hiding the insanely complex inner implementation details and only exposing the essential, high-level features to the user, or frankly, to the other developers who have to use your code. In Java, we achieve this incredibly clean separation mostly by using abstract classes and interfaces.
It's a lot like driving a car. When you get behind the wheel, you use the steering wheel and the pedals, right? You don't need to understand the crazy mechanical details of how the fuel injector is currently mixing air and gas just to get from point A to point B. You just interact with a simple interface. The code snippet perfectly mirrors this. Public interface car, void drive. You're just giving other parts of your program a super simple drive command, completely hiding the dizzying hundreds of lines of engine logic happening behind the scenes. And guys, this radically reduces the cognitive load when you're buried deep inside a 100,000-line code base. It forces you to focus entirely on what an object does rather than how it does it. By shielding developers from those fragile underlying mechanical details, you physically prevent them from accidentally destroying the engine while they're literally just trying to drive the car.
Finally, Section 6, the maintainable codebase. Let's bring it all together.
So here is your fully summarized blueprint for preventing the spaghetti code nightmare. Step 1. Shield your data with encapsulation so it simply can't be corrupted from the outside. Step 2. Reuse your code with inheritance so you establish a clean, single source of truth for shared traits. Step 3. Flex your object behaviors uniformly with polymorphism so you can completely avoid rigid, buggy conditional chains. And Step 4. Hide the messy internal complexity using abstraction so your team only ever interacts with clean, simple interfaces. Look, these are not just boring academic terms to memorize. They are the literal practical toolkit you need to survive large-scale software projects. So I want to leave you with a provocative question to really chew on. When you sit down today to write your very next line of code, are you going to use these 4 pillars to build a rock-solid, scalable foundation? Or are you just adding another noodle to the spaghetti? Thank you so much for joining me on this explainer today, and happy coding.